So hello and welcome to our channel, everybody. So today we're gonna do D1 chapter 1. So let's begin. D1 chapter 1. It's basically we're gonna do exercise 1A concepts, and in those concepts what will come that lies ahead. So basically, we're going to do a short recap. It's going to be in a little detail, but it's still going to be considered as a recap as we study in our primary school. So in that recap, you're going to do prime factorization, prime numbers, composite numbers, and index notation. Let's begin now. So first, we're going to do 1.1 prime numbers and composite numbers. This is the first chapter, the first beginning. So factors. Basically, we've learned about factors in our primary school. And factors are numbers that multiply with each other and give a result called product. That is, for example, we have the number 18. So 18 is the product of the factors 18 and 1, and 1 and 18 are the factors of the product 18. So basically, that's the relation. So over here, now we know we can represent product with P and factors with F. So basically, let's find the factors here. 18 is a product. 2 and 9 are factors, so we can just write F. And same goes here. 18 is the product of the factors 3 and 6, so this is the factor. So therefore, the factors of 18 are 1, 2, 3, 6, 9, and 18. Now we have to classify the whole numbers. So they're classified into even numbers and odd numbers. So even numbers are divisible by 2, like 0, 2, 4, 6, 8, and odd numbers are not divisible by 2, like 1, 3, 5, 7, and 9. So next we have prime number and composite numbers. Now prime numbers are different type of numbers. Prime numbers is a whole number that has exactly two different factors. That is 1 and itself. Suppose 2 is equal to 1 multiplied by 2. These are two different factors. 1 is different, 2 is different. Two different factors, and there are only two. That is 1 and itself, 2 itself, 1. So that it is a whole number, so it will come in the category of a prime number. But composite number is a whole number, again, that has more than two different factors. Like 6 is equal to 1 multiplied by 6 and 2 multiplied by 3. So basically here, 1 multiplied by 6, that is 1 and 6 are factors of 6 and 2 and 3. So this is a composite number as it is a whole number and has more than two different factors. So as we know, like for example 2, like as we said before, 2 has only two factors, which are 2 and 1. And the number 1 is not a prime number. As we know that what are the criteria that comes in a prime number, that is whole number that have only two factors. Now look at 1. 1 is not a prime number nor a composite number. Why? Because as we said, composite numbers is a whole number that has more than two different factors. And whereas 1 here has only one factor, that is 1 is equal to 1 multiplied by 1. So this is a natural number, a normal number, odd number. Because 1 has two factors. Has one factor. This is 1 multiplied by 1. It is the same thing. All right? Same thing. So this is not a prime number nor a composite number. Now let's find the prime numbers from here. So now we know it becomes hard, but we'll still find them. So this is basically what happens in our examination, that we're given a grid and we have to find it. So firstly, we're gonna cross out, we're gonna circle 2, 3, 5, 7. All right, these are the basic ones. Now as 2 is the only prime number, that is only even number that is prime, so that will get, there is no more even prime numbers, even prime numbers, so we'll cancel out rest of the even prime numbers. So let's cross it, cross it, cross it, cross it, cross it. So now we'll cancel all this line 2, this line 2, this line 2, and even this line. Now, as we know, it is really hard for us to find it right now, so we just learn the prime numbers just like that. So they're mainly in threes. You will find them in the number with the denominator 3, 1, 5, 7, or maybe 9. So I'm not just saying that these are the prime numbers here, but we can see in this list that it is 2, 3, 5, 7, 11, 13, 17. As I said, 1, 3, 7, and 9, basically there will be no even number in the denominator. One thing you need to remember, that there will be no even number in the denominator, in the units place, or there will be no even number as a prime number. Only 2 is the only even number that is even a prime number. So these are some facts, keep it in mind. Now, composite numbers. A composite number is a whole number which has more than 2 factors. For example, we have 6. 6 is a composite number as it has more than 2 factors, which are 2 and 3 and 1 and 6, as I showed you in the example before. Now, the next topic, we have index notation. We have learned in primary school that possible units for area and volume are centimeter square and centimeter cube respectively. For example, the area of the square with the size 5 centimeter. Now, I know plenty of you might be wondering what's area. Maybe you've done area, but generally we just leave area for now. Just remember, when we say 5 multiplied by 5 is equal to 5 squared, this is the easier form of writing it. This is called index notation. This, because this is the index. All right. As you know, index on the books are like chapter 1 is this, chapter 2 is that, and blah 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 blah. So here it is some kind of that, but not exactly that. So this 5 square on top is going to be read as square, like 5 square. And if we say 5 multiplied by 5 multiplied by 5 is equal to 5 cubed. So like this is cube. Now what if there's 4 5s? It will be read as 5 to the power 4. This is its power. Means we will multiply 5 for 5 4 times with itself. Like 5 multiplied by 5 multiplied by 5 multiplied by 5. This is called index, where 4 is called the index, as I said before. And 5 4 is called, or 5 power 4 is called the index notation of 5 multiplied by 5 multiplied by 5 multiplied by 5. So 5 multiplied by 5 multiplied by 5 multiplied by 5's index notation is 5 power 4. Easy. Now, as we see this example, like there are how many threes? So technically, just like divide them into 3 parts, into small parts. So this has 3, 3, 2. So we will just add it like this. So now let's continue. Basically, there have been some. So now let's continue with where we were before. So now as we were doing this. So I was just telling you The 3 multiplied by 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 3. So that was total how many times? We did this 3, 3, and 2. So 3, we'll add this 3 plus this 2. So 3 plus 3 is 6, 6 plus 2 is 8. So now we would say like it is not 3 multiplied by 8. This is the common mistake we make. Instead, this is 3 multiplied by 3. Mostly right now we'll write it like this. But while we're expanding it, we would write 3 multiplied by 8. No, this is wrong. No, we will write this. That means it is multiplying by itself 3 times, 8 times. So now let's take this example. 6 multiplied by 6 multiplied by 6 multiplied by 4 multiplied by 5 multiplied by 3 multiplied by 3. So now this is pretty complicated. Now I would say let's take, for example, this 3, we'll just divide in it. We can't make like 6 multiplied by 4 multiplied by 5 like this, so we're just writing it in index notation. This is mostly the questions we get. So that's how. So we'll even do a worksheet of that in our next video. So right now I'm just telling you what you have to do. 4, this is even 1. Why did we write 4? We always do this mistake and this must not be done. We'll just write 1 because this is 1 is its power. 5, this is 5's power. And this is 2. So we will write it like 6 cube multiplied by 4. Power 1 is optional. Power 1 can be written normal because you just like means 4 multiplied by 1 time itself. So that will be 4 multiplied by 3 square. So this is what most questions come like. Exactly this. Or they can even say expand this. So basically, as we said, it's the same thing. So now the main concept comes in prime factorization. Now prime factorization means taking out factors of a number. Like suppose we take 18. 18 is a product of the factors. Now prime factorization means, as you know, factorization means taking factors out of a number. But in prime factorization, we will take prime factors out of a number. Like suppose 18's factor is 2 multiplied by 9. Which can be even written like suppose 18 is equal to 2 multiplied by 9. Can 9 divide by some number to become a prime number? Yes. 9 divided by 3 is equal to 3, and that is a prime number. So this can even be written like 2 multiplied by 3 multiplied by 3 means 3 3s are 9. So now we know that this is prime factorization, taking out prime factors from a number. 18 might not have prime factors, but we can at least divide the factors in it to make it prime. This process is called prime factorization, and we often confuse prime factorization with normal factorization. So we must remember, what does it mean by prime? Prime means, as we learn, prime numbers that have factors 1 and itself. Only those numbers will be considered as the factors of any product if you're taking prime factors or we are doing prime factorization. Now for example, we have 6, 2 multiplied by 3. So now here 6 is the product of the prime factors 2 and 3. 2 is even a 2 and 3, and 2 is a prime number and 3 is even a prime number. So now after that, we're going to do 1.2 square roots and cube roots. That is nice. This is another concept based thing. So this will help you in exercise 1A. Cube roots and square roots. So cube roots, basically, we have learned in primary school that the volume of the cube has 5 edges, 5 multiplied by 5 multiplied by 5. So now you don't need to learn this. So just remember that 5 multiplied by 5, as we learned it before. Didn't we learn it before? Here, index notation. It is so easy. It's just something like that. These are all interrelated. So we have learned in primary school that the volume of the cube with the edges is this. So just like say 5 multiplied by 5 multiplied by 5 is equal to 125. Now what step we've missed? You say, why isn't it 5 cube? Because we skipped this step and made it 5 cube means 5 multiplied by 5 multiplied by 5 is equal to 125. As simple as that. No confusion, no rocket science. So we've learned this, blah, blah, blah. So the cube root is the opposite of the cube. In a cube root, we divide the number 3 times equally. So like this, 5 multiplied by 5 multiplied by 5. 125 is divided by 3 times equally. Is divided into 3 times equally. Yeah. So that is, and in cube, and that is cube root is the opposite of cube, and in cube we will multiply the number 3 times what itself. Like here, 5, this is the index, cube is 5 multiplied by 5 multiplied by 5, 3 times. That will become 125, and this is the basic example. So now let's do square root. So similarly, in square root, we will divide the number 2 times, or divide into 2 parts equally. So square root is the opposite of square, as we know. And one example is given, 5 multiplied by 5 is equal to 25. As we said, 5 multiplied by 5 can even be written as 5 square is equal to 25. Now this comes the hard part. This is pretty complicated, as we said that this is a little complicated. So we're just learning this. We're doing a little basic, so we're still doing it. Right now you will understand a little bit, but as soon as we do the questions that we are going to do, you will understand that how are we going to apply all of these together, index notation, square root, cube root, and use it in one question, because every question it needs these things. These are such basic concepts. Now we know 25 square is 5 multiplied by 5 is equal to 5. We know that, right? So that's there should be no difficulty in that. No, not at all. So now there should be a square here. That is 25. We will have to divide it into 2 parts. So it will be technically like 25 is equal to 5 multiplied by 5 is equal to 5 squared. We cancel this. Is equal to 5. That is so easy. So that should have no confusion at it. Now we know that we have to cancel it. First we have to divide into 2 equal parts. Divide into 2 equal parts. Then that will become 5 multiplied by 5. That is 5 square, and we'll cancel the square. So now let's solve the exercise 1A main questions. This is a basic. If you know these questions, we can do the whole thing. Then we're gonna do a worksheet in our next video. So now first let's do this. So question one, determine whether each of the following is a prime number or a composite number. So first we're gonna check its factors. So now let's see how many factors does 87 have. So we will check the factors. Now first remember we have to divide in different numbers and it has factors like 29 multiplied by 3 and 1 multiplied by 87 is 87. So that means when it has more than two different factors, like this is one factor, this is two factor, this is 3 and this is 4 and this is a whole number and it has more than two different factors, so is it not a prime number but it is a composite number. Now 67, we'll find the factors again. Now 67 has only one factor. So therefore, when it doesn't have one factor, it has two factors. When it only has two factors, it is considered as a prime number. So yeah, it's considered as a prime number. So now find the prime factorization of each of the following, leaving your answer in index notation. Now this becomes a little tricky here. Now what are we going to do and how are we going to do? For that you can use a factor tree. That is the easiest method found here. So now let's tell you how I did it. So now basically this is the main method everywhere. Now 72 divided into two numbers. Find any good factors of it, not like 1 multiplied by 7, to do some other factors. Like it's an even number, so divide by 2. So 36 multiplied by 2. Now we will divide 36 even more as we need factorization and we need an answer in index notation. So now let's say 36 multiplied by 2. So now 2 is a prime number, it will be carried on like that. And 36 can be divided into more numbers, that is an even number and it is not a prime number. We will keep on dividing until it doesn't reach its prime value. Oh, what have we done? We often make these mistakes, so we gotta check these things. So now 6 can be divided into 3 multiplied by 2 into see its prime factors, not 1 multiplied by 6. What's the point? When we have to divide 6 again and then its factor will be 6, it will never get divided. So choose the factors that are prime here now. Because we can't find prime factors here, so there is no lame excuses. We gotta do it. So now let's multiply. Let's take this 2 here. Now we have this prime factor, so we will write 3 multiplied by 2 multiplied by 3 multiplied by 2 multiplied by 2. So that is how many 3's are there? 2, so 3 power 2. And we can only do it. Now suppose I say 3 multiplied by 2 is not going to be equal to this. But 3 multiplied by 3 is equal to 3 squared. That is correct. So now let's do it and 2q. So now this is basically what was important. Now see, our answers is absolutely correct. So now let's see 630. This is a big number, but we shouldn't get worried. Look, big numbers are supposed to and will obviously come in the exams. So if you practice a little bit now, it is good. And I bet you can use a calculator on this, or you can use your common sense too. Now see, so for example, 630. Now, how are we gonna divide 630? We can divide by 10, but we want on one side, like how we divided here, one side should always be prime. Try your best to do always one side would be prime. Or maybe it's not prime, but here it can be prime, right? Because this is 0 and this can be divided by 5. So now let's make it. Now 630 divided by 5 is equal to 126 multiplied by 5. Now we can divide 126 into 63 multiplied by 2 multiplied by 5. Now we can divide 63 further into 21 multiplied by 3 multiplied by 2 multiplied by 5. Now we won't touch these things as they are both the same. 5 is a prime number, 2 is a prime number, 3 is a prime number. They are not same, but they're all prime numbers, so now we won't deal with them. We'll deal with 21. It's prime factorization. Now we will divide 21. That will be 7 multiplied by 3 multiplied by 3 multiplied by 2 multiplied by 5. So basically that's it. So now we found this. So now let's find it. Now we did this. Now we'll write it. 7 multiplied by 3 multiplied by 2 multiplied by 5. What have we missed? We often do these mistakes. 3. Now we have to check one more time. Is our answer correct? Just recheck it quickly. Did we miss any prime numbers? No. So 7, 1, 3 are 2 times multiplied by 3 to this is not necessary. The index notation of 1 is not necessary. 5 multiplied by 2, 1, 1. So now let's see, it is done. So now let's use the prime factorization to find each of the following. Now comes the tricky part, who I said again and again that we will always, these things, square roots, cube roots, everything is interlinked. Now comes the hard part. Now comes the part where we have the most issues. Now for that, we might need to know LCM, or even not LCM, we'll just do this. All right. Now this is how we do prime factorization. We will take some value here, 1764. It is an even number, so we'll divide by any even prime number, that is 2. Now this is 1. No, this is 8. 8. 2. Usually sometimes you're allowed calculators in this part, but it depends where you're studying. You are studying in a Cambridge system or any different system, but this is basically Cambridge book, so we are studying Cambridge. Now 882 can be divided by 2 again, as this will divide into 441. Now 441 is not an even number, so, and let's see, it can be divided by 3. So let's divide it. 147. Now divide again by 3 because we know we can divide by 3. Let's try it. So that is 49. Now 49 is obvious. That 7 square, 7 multiplied by 7 is equal to 49. So we know that this is the basic thing. We've been learning it from so long time. Or by the way, we should have known these small squares. You should learn because they come in mental math. So I think so you should learn them. So 7. Now 7 divided by 7. Now 7 divided by 7 is 1. So now let's see. This 2 times, this 2 times, and this 2 times. So now let's see. Some people say, how do we make squares? So now it's just like a tick and this. So I've been practicing on them like for ages. Now let's continue on our lecture. Multiplied by 3 square, add brackets, 7 square. So again, add the square. That is, we'll find the common, or we can just do it like this, as all of them have squares. We can just combine into one square, can't we? So now let's see this. So this is a little tricky. Not too, how are we gonna solve it? This is just gonna end up here. So now we know that we can cancel this 2 and this 2. It can even be done with cube root. And in the worksheet, we'll have special examples. So now let's find 2 multiplied by 3 multiplied by 7. Usually they're always written with prime factorization, as this is the easiest method to solve this. Otherwise, it is really hard to solve it with this. So 2 multiplied by 3 multiplied by 7 is equal to 42. So that is easy. That is easy. We know our answer is correct. So the end. This is the end. So like and subscribe and leave a comment below. And if you have any doubts, any problems, you can even write them in the comments below. And if you want us to make a video on some specific topic you don't understand or you want our studying it, so we will try our best to help. So goodbye.